Hello, everyone. My name is Sowmyan Soman. I'm a Principal Partner Solution Architect at Microsoft Global Partner Solutions Organization. In this short video, I'm going to cover what is LangChain and how we can use it with Azure OpenAI. The primary objective of this session is to cover why we need to use an orchestrator like LangChain, and then what is LangChain and how we can use it. So before we getting onto the why part, let's see how a GenAI project lifecycle look like. It's always start with the business use case. So you need to define the business use case that you can leverage a generative AI to solve that particular business problem. And then once you have the business use case, then you need to start with an LLM or foundation model. There are different varieties of LLMs available, especially from Azure. We can use and manage service like an Azure OpenAI. And then once you choose your LLM, then you need to making sure that that particular LLM is providing the desired response and output to resolve the business use case that you have. And it's an in this particular phase, we can call it as an adapt and alignment with the business use case. You can start with the basic techniques like say prompt engineering. You can you can give different types of prompts and see how you are getting the response from the LLM. And this particular phase, it's going to be more of an iterative process. You will be continuously evaluating the response, and then you will be improving your prompt to get the desired output. And there are other techniques like fine tuning. Fine tuning is primarily to provide a large data set, at least 200 examples with a human label data, and you can train your LLM to adopt that particular business model or a domain model. And the third category is retrieval augmented generation or RAG. This is a very common method that we are seeing with our partners and customers, and it's a very efficient model that you can use for adapting your LLM to to equip your business use case that you have here. And once you have your LLM ready with all the different techniques that you used here for the adapt and alignment, then you can start integrating your API. Basically, at the end, it is going to be exposing as an API, and then you can integrate that one with your application. And during the application integration, you can also think about some optimization techniques. Like, for example, if you're using Azure OpenAI, if you need to get some predicted performance and throughput, you can even look for assigning a PTU. So that is another technique for especially for the production environment, and you can start integrating with your application, and then you can monitor your application. We'll be covering all these topics later, and especially how we can use LangChain in these particular scenarios. Yep, I think I forgot to put this animation here in the adapt and align scenario. Yeah, it's an iterative process. So after evaluation, you can keep changing the prompt engineering techniques or the modification what you need to do for either fine tuning or retrieval augmented generation until it satisfies the business use case needs here. So let's get into the limitations of LLM. The primary two limitations is that outdated public knowledge and no internal domain knowledge. What does that mean? Outdated public knowledge means this very large LLMs are, especially if you take the GPT-4 or GPT 3.5, these are the LLMs which are trained with a very large amount of data publicly available, of course. And this particular training of it took like days or weeks or even several months to complete and consuming a large amount of GPU. So if you have such LLM and if you're asking some information that is, let's say, happened today or yesterday, that is very difficult to get that from the LLM, because LLM is already trained with a data set which is available might be several months ago or a year ago. And another common limitation is the internal knowledge. So similar case with this training public data set here, and LLMs may not have the information about your internal database or some document store that you have. So how you can supply that information to your LLM and get a desired response from the LLM when you ask specific questions related to that. So in this case, you can see in a screenshot, and for the public knowledge limitation scenario, we are asking a question about write a model class using latest version of Flask SQL Alchemy. In this case, it's clearly not the latest. So what the assistant is providing here is that the response is already a trained data set, what it is used in the training time, and that is the information it has. And for the internal domain knowledge scenario, let's say I'm working for a company. I want to know if my company provides some benefits for underwater activities as a perk, company perks. And then, of course, the LLM is not aware of that information. So we will see later how we can make your LLM get to work with this kind of scenarios. We covered these details in the previous slide. So primarily for internal domain knowledge scenario and to get up-to-date information, there are primarily these three techniques you can use. Prompt engineering in context learning. That is something like when you provide the prompt, you can even provide the detailed information. So this is not like a scalable approach for all different use case here. And fine tuning is another option. You can permanently provide this particular updated information as a new skill, but here it is going to be a bit cost expensive here, as well as it's a time consuming. And RAG, or retrieval augmented generation, is a good approach, or an alternate approach for getting rid of these limitations primarily. So this is what we are going to cover, and we will see how we can use an orchestrator. So how exactly RAG works? So in my previous question about the limitation we talked about a couple of slides back, do my company perks cover underwater activities? So when a user asks this question, what exactly going to happen is that first we need to retrieve this information from your internal database store. So it could be a vector store, and you can ask about the similar question into that, and then we'll be getting a output related to that question. And that output, what we are going to do, that we are going to supply that information with your large language model along with your question. So now LLM have that in question, as well as the context with some information that you got from your internal storage system, and now LLM can respond to that. So this is a retrieval augmented generation part. And then if you look into the same questions and details that we have seen in a couple of slides back, you can see this would be the response. You can even provide some citations to the internal data that you have, and you can provide more valid response to your questions. So now we'll see what is an orchestration is going to be helpful here. So as you can see that in a RAG, there are multiple pipelines are coming to the picture. You need to push the data into a vector store, and then once you are searching for the data, you need to retrieve that information and supply to the LLM. So an AI orchestrator like a LangChain or semantic kernel, there are multiple other open source version of orchestrators available, and these all are the it's a nothing but an SDK going to be helpful to implement that orchestration pipeline what you are going to implement. So what is LangChain? LangChain is a framework for developing applications powered by LLM. So LangChain started with the core library component primarily for Python and JavaScript, and you can integrate this SDK in your applications. And LangChain community, there are many different tools and components are available. And LangChain expression language, that is that's a great capability available in LangChain to making your implementations very easy, even from a developing from a scripting perspective. And LangChain is also providing a chains concept, like you can chain a sequence of different tools and different activities, and you can build something called an agent will act as an assistant to retrieve the information from, in this case for the RAG scenario, you can create an agent to pull the data from a vector store, and you can augment that information to LLM and provide the response. And LangChain also coming with a different templates now, so you can pick a template if you want to go with an off the shelf solution, and you can build that particular application based on that. And once you have built that, you can even deploy it as a another component called langserve. So langserve is going to expose that customization what you have done as a REST API, and you can host that one in anywhere, like even in Azure. We can publish in Azure Container Apps, for example, as an API in a serverless model. You can deploy that way. And Langsmith is another component. Is going to be helpful to monitor and debug your application while you are in the developing mode. So we'll be covering all these details in a very high level. Not really all, but my intention is primarily to cover some of the key concepts here. So before we get into the demo, let's see if I'm using LangChain in Azure for building a Gen AI application, how exactly it look like. Where are the places I will be using LangChain? So in this case, for the RAG scenario we have seen earlier, first thing is that we need to make sure that this particular internal domain data is available in a vector store. So there are several advantages for putting the data in a vector store. There are related sessions you can find in the series to identify what are that. And in this case, what we are going to do that, let's say, going back to the scenario that we have seen, let's say I want to know my company perks for different scenarios, and I need to ask the question to an LLM. So the first thing is that since the LLM doesn't know about my company perks, I need to feed that information somewhere so that I can retrieve the related information and I can send to LLM. So the first thing is that in this case, let's say the perks information is available as a document. I can push the document into an Azure Blob storage. And if I want to really automate the entire pipeline, the data ingestion pipeline, I can trigger the blob upload event as an event grid. And then run some code I can run some code to process that particular document. In this case, what I'm going to do that, you can see I'm using LangChain to process that document, and I can use a service like Azure Document Intelligence Service. Let's say if it is a PDF document, I can I can intelligently retrieve the necessary information out of the PDF document, and I can create an embedding version of that particular data, and I can push that information into a vector store. In this case, using Azure AI search. So once we have the data available, then what we need to that the user will be asking a specific question. And in this case, let's say you build a single page app, and that app is going to interact with your LLM. It's going through a layer 7 gateway here, and then it is hitting the container apps. So I'm exposing this particular LangChain based API in Azure Container App. And what it is going to do that, again, this is a retrieval flow, what we are going to see here. It is going to create the embedding version of that particular question, and then it will be asking the same question to Azure AI search here, and then we'll be getting the necessary information back. Once we get that information back, we are going to send that detail along with the user question to the actual chat model. In this case, it's a GPT-4. And then once we get the response back from GPT-4, you can even store that information in a in-memory cache like a Redis cache, and then we can use that information for the future conversations with the user. And you can even store some related information in Cosmos DB for example, for the operation scenarios, operation database, you can use as a Cosmos DB here. And that's how it works. So if you map then their RAG into an Azure world, this is how it looked like. Of course, it's a sample reference architecture, and then you can see which are the areas you can use LangChain. You can use LangChain for the data ingestion pipeline, as well as you can use with your retrieval scenario. All right. So now let's get on to a quick demo of LangChain. So this particular sample was created by my colleague Shiva. You can find this information in this GitHub repository. and it's a public repository. You can go ahead and clone it, and once you clone it, you will be seeing the details how we can use LangChain. Typically, before you expose your API, you can even test it out LangChain in a notebook. So you can find different notebooks here for processing the data, indexing the data, primarily to how we can store the data in a vector store like Azure AI Search. And Shiva did a great job of like splitting the LangChain concepts into multiple notebooks here. So if you want to explore what is chain, what is agent pipeline look like, and what is an end-to-end agent. So we'll be seeing a couple of these notebooks, and we'll be going through that in detail. So before we getting into that, let's go and see what is LangChain and where we can find this information. So langchain.com, if you look into that, you can find all different components what we are talking about, and you can explore that. And then if I get onto the introduction section here from the documentation, this is exactly we were talking about in the slide. So I would recommend you to review this information here. It's a constantly it's evolving, so it's a better to always refer the documentation to get the up to date information. So you can see all these components and details here, and then you can also find the specific section for Microsoft. So if we come back into the provider section, and under the integrations, if we come into the provider section, and you can see Microsoft, and then you can see what are the service available from the Microsoft stack that you can integrate with the help of LLM and LangChain. So, for example, if I want to work with Azure OpenAI or Azure ML, how we can use LangChain. So that's the examples you can find here, which are the package or module that you need to use. And for document loaders, this is primarily for the pipeline scenario that I have showed earlier, that to ingest this documents into a vector store, how you can handle that one with the LLM. So there are different document loaders available, vector store, Azure Cosmos DB available, and retrievers. Azure AI Search you can use as a retriever here. So LangChain is providing the necessary libraries to manage all these components. So I highly recommend, if you're working in Azure, come into this integration section, and you can look for the Microsoft providers, and you can see what kind of services are currently it is supporting. And this I would cover later. Let's getting into this details. And Langsmith is another tool is available to primarily to debug and monitor your applications. In this case, I'll go through this detail how we can integrate this. This is going to be very helpful if you're developing the application. Let's say when I developing the application, I want to know what's going on and how many tokens it is being generated by by the LLM, and even from the user input. So if you want to see all these details, what's happening behind the scene, and if you want to monitor your application in both the development as well as in the production environment, this is going to be really going to be helpful. So now let's getting into the VS Code, and then I have cloned the repository that I showed earlier. And once you come here, you can see all these notebooks here. So one of the best practice, at least we were following, I worked with Shiva as well on this one. So when you are in that exploratory evaluation phase that we have seen in the GenAI project lifecycle, you can even start with a simple Jupyter notebooks, and you can test it out with all the capabilities. And then once everything looks good, then you can even move that data into move the code into an API. So in this case, in the same repository, you can also find a fast API implementation of the same, and you can find some of the best practices how we can even move the code into the routers, and how we can implement this. So you can look into both the ways, and this is an API version. Once you get into the app folder, and in the notebook section, you can see all the necessary information related to LangChain in a Jupyter notebook. And the data folder is primarily for just a simple contoso JSON file. This is what we are really pushing into the vector store. and then we will be indexing the data using Azure AI search, and that is what we are going to use for retrieval. Okay, so for a quick demo, I'm not going to cover all these details here. What I will do that I will just show you how we can use the agent. So the agent is another great feature of LangChain. Let me open it up here. So if I go back into the chatbots or tool use, yeah, here you can see that. So if I want to make an intelligent assistant for a particular business use case, then an agent would be a great way of implementing using LangChain. And so agent provides multiple capabilities. So you can see that it is providing a list of tools. So when I send some information to the application, that application can find the right tool to use. The tool is, you can think about, the tool could be retrieving some information from an API or from a data store, or it could be as simple as creating a formula or a calculating something on the code. So if I want to do that, you can create a list of tools and we can provide that one to your chain, and the agent can use that one on the fly in a sequential or parallel model, and then it can execute that information and it can send that necessary data to your LLM, and it can get the response and back to the user. So this is exactly we have implemented in that sample notebook we have, as well as the API version as well. You can find it. So now if you go back to this code, let's see what are the components we need to use. So primarily, if you want to use the LangChain, in this case, I'm using the LangChain embeddings. So this is primarily for the retrieval augmented generation. If you notice this particular scenario, let me just move the slide here. We are talking about OpenAI embedding. So when I send a request to the LLM with the help of LangChain, we'll be making a OpenAI embedding version of that particular user query, and then we will be sending that to the vector store to retrieve the necessary information, and then that is a output. What we are getting from the Azure AI search is what we are going to send to the LLM to augment. So in order to do that, I need to use OpenAI embedding and the Azure AI search. That is what we are going to use as a vector store, and we are using the tools SDK. So we'll be using a number of tools, and one of the tool we are going to use as retrieving the data from vector store, and we will be using Azure OpenAI function calling capability as well. So all this information is all the keys and necessary variables, values, everything is configured in an environment variable here, and we are loading that information. That is what we are doing here. And now once we have this information ready, then this particular code snippet is going to connect with the langsmith. So now once I execute anything here, all this data would be sent over to the langsmith. So you can see that information coming in the langsmith portal here. If I go back, yep. So in Langsmith, basically you can segregate all of your projects isolated model. Like for example, in this case, I have two projects. One is for coffee shop demo, and another one is a Condoso agent. So this Condoso agent is a project I'm using in my VS Code Jupyter notebook here. So when I'm testing something with my Jupyter notebook, if I want to explore what's happening, I can come here and I can see all that information available in this particular category. So I'm going to put it in as like a last 1 hour of data, so that it won't be giving a lot more information than what we need here. So now the next section, we are going to load all the necessary environment variables, and then we are also declaring the vector store, in this case Azure search as the vector store. So that is a good advantage of using again LangChain. So you can declare a generic vector store, and in this case Azure search is provided here, so you can integrate that vector store as Azure search. And then what we are going to do is we are going to import tools, and with the declaration of a tool you can define what is the tool exactly going to do. So basically the idea is, again, going back to our retrieval augmented generation scenario, we are talking about this flow, the number 12 here. So in order to accomplish this particular part, we can create that particular retrieval as a tool, and that is what we are declaring. And this is a symbol as a function, and you just need to declare as at the rate tool, and you can pass the question, and you can provide the necessary parameters what you need. In this case, we are going to use the vector store hybrid search capability. There are multiple ways we can query the vector store. We are going to use hybrid search here, and once we get the data, we will be returning that one from this function. So if I execute this, you can see that, okay, so we got this function. And if I execute what French coffee option bake and bakery items do you have, you can see that this data is directly coming from Azure AI search, and that is what it is returning here now. And then, so if I go back to again our PowerPoint slide, so the response we will be getting here from number 12 and then number 13, to we'll be passing that information to the actual chat model, in this case GPT-4. So this would be the, so for debugging purpose, you can see that we are getting the response directly. And then what we need to do, that if you can have more than one tool. So once you have all the tools, you will be adding into a collection. In this case, it's a tool list here. That is what we have declared. And if I go back into our code here, the documentation, let me just close all this information what we don't need. Yep, so you can see that, so the tool is you can create as a collection of tools, and that is what we are doing. So in our case, one of the tools what we are building is a retriever, and that retriever is going to pull the data from Azure AI search. And you can see that now you can see with the LangSmith integration, the query that I just executed from the VS Code, the one that we just executed here, that has been already captured, and you can see it is running as a tool. That is a sign for this, and you can see that what was the input, what was the output. So you can see LangSmith is going to be helpful for the entire activities happening under the context of using LangChain. So it's not just for the LLM interaction. In this case, the tool, which is a direct interaction with the Azure AI search in this case, and you can see what's going on with the tool, and you can easily debug the application here. So now we are going back here, and let's see what are, so now what we're going to do, that the another great capability is Azure OpenAI has is that function calling. So the LLM can identify, for this particular question I need to use a specific tool. Let's say you have 5 different tools and I'm asking a particular question. So based on that question, OpenAI function calling capability can identify which tool or which function to use. So that is exactly we are going to leverage here. So using LangChain, we are converting the tool what we have into OpenAI function. So now you can see that once you do that, it is generating the same tool what we have declared into an OpenAI function, and this is a schema for that. So you need a name, description, and what is the type and properties, and what are the required parameters that you need. So that is a pretty cool capability. So you're working with Azure OpenAI, you can convert the tools what you have into a OpenAI functions, so that we can leverage the function calling capability. So now after so what we have done so far is we declared some of the variables. We created a retriever tool, and we converted the tool into OpenAI functions. Now in this section is what we are going to declare the chat model. In this case, we are using Azure Chat OpenAI, and that is the one you can use for the hosted version of Azure OpenAI. and you can pass the necessary variables here. In this case, we are turning off false as for streaming, but you can find this one is on for the API once you are in the production environment. One of the best way to get that streaming capability, the word by word rendering of your response, is going to be making the streaming as true, and that is something you can do that. And then in the same model, we are going to bind the functions. So that is another great capability of Azure Chat OpenAI. All right. So the next part, let's continue looking into the how we can use the chat model with LangChain. So one another great capability of LangChain is the chat prompt template. So you can create a prompt template, and you can. Good thing is that you can even dynamically put the data here. Like for example, in this case, I'm creating a meta or system prompt, saying that what is the capability here, and we are defining a character to your assistant, and then you can pass a human input. So for this particular meta prompt, I will be passing whatever the user query what we are getting here in this particular template. So that is a great advantage of LangChain by leveraging the prompt templates. There are different prompt templates available. In this case, it's a chat prompt template, and I'm defining the prompt. We will be expanding this chat prompt template by introducing the memory and all these capabilities later. So for now, what we are going to do that we will declare the chat OpenAI, and we have defined the functions, and then we have provided the prompt template. And now we are creating a chain. In this chain, we are passing the prompt template what we have created here, and the model, which is the Azure Chat OpenAI. And then we are going to say that Azure OpenAI functions agent output parser. That is a output of this. So we are in this chain. This is again another example of the LangChain expression language. You can easily pipe all these components together, and that's how it is going to execute in the chain. I'm going to execute this code block now, and then we'll come back. Now, if I'm asking a specific question, so far we are ready with the chain. In this chain, we have defined the chat template and the model, and we are going to use the tools as a function call with the OpenAI. So now if I call the chain.invoke, and then if I pass input as what are your French coffee and bakery items, the data that we have is related to a coffee shop. So now let's see what exactly we are going to get as a tool and tool input. So once I execute this, based on this query, it will be identifying the tools what we need to use. You can see that for anything related to this coffee and bakery items, we have defined a tool to retrieve the information from Azure AI search. And then you can see that it is also mapping the tool input. So for retrieve tool, if you go back here, you can see that it need two parameters. One is hard coded here, so you don't need to pass it as a dynamic. In this case, a question need to pass as a string variable as a parameter into this function. So the advantage is once you have defined all this information here, the tool it's already identified, and tool input also already created. So now it will execute that information behind the scene once I execute that chain. So now if we use a result.message log, you can see how exactly it is going to be using with Azure Chat OpenAI as well as the function call. So that since the tool has been converted into an OpenAI function call, you can see the necessary argument, all the details, how exactly it is going to pass. And you can, using the result, you can see that, okay, once I execute the retrieve tool, which is nothing but a function here, and if I pass the tool input, what is it been generated, you can see that now we are getting the actual result. So this is going to be helpful for, again, troubleshooting scenario, especially in a Jupyter notebook. You can execute that actual tool, and you can see how is that desired output you are getting. And I'm going to skip this part here. Again, this is primarily to test it out at different options. But what I want to show you is primarily how we can use the agent executor as well as the memory capability. So agent executor another built-in class available to run this agent. So what you have to do that you will be declaring the agents and your tools in 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 the previous section, and then what you need to do is just create an agent executor instance by passing the agent is nothing but the chain that we have created, and then pass the tools list. In this case we have only one tool, and once you pass that you can execute the agent directly and you'll be seeing all the information. I think I need to execute this part which I missed, and then you should be able to see the output coming up from there. And then at the same time, let me also open up the langsmith. You can see the same Langsmith is now tracking the agent executor class, and you can see even before you can see that the error message that we got. So these are the great capability of using Langsmith live, so you can troubleshoot the issues. So you can see what's going on. You can see behind the scene, it's doing a lot of things. It's running all this chain in a runnable sequence, a parallel mode, and then you can see what's going on in each one of this execution in detail mode, and you can troubleshoot them. So this is going to be very helpful. Going back here, okay, now we got the response. So you can see this was user input and what was output we got. And the final thing I want to show you is about how we can even declare and use and memory. So let's say you're interacting with an agent, and if I need to store some information about the details that I have given to the agent earlier rather than repeating that information, in that kind of scenario, if you need to get the real benefit of a true agent experience, virtual agent experience, you need to have a chat history stored somewhere in a memory. So in this case, we are using a placeholder. So every interaction with the LLM, it will be using this message placeholder with the chat history. So if any information I have supplied in that chat history, you can get that information from it, and LLM can respond accordingly. So that is exactly we are doing here. And for memory, you can that is another advantage of using LangChain too. LangChain is providing different memory options for building an virtual agent. So in this case, we are using the conversation buffer memory. In the actual API, we will be using Cosmos DB. You can even use Redis cache. So you can store all this chat history in that kind of a persistent store, and you can execute your agent. And so all the interaction, it will be storing that information in the chat history placeholder, and you can see the chat history contains the name in this case. So next time if I ask my what is in my name, it knows that I have already supplied that and it is already available in the chat history, and it can retrieve that information. So that is a main advantage. I'm only covering only few things here, and I just want to introduce this repository with all the samples what we have built for integrating LangChain with Azure OpenAI. So I would strongly recommend to review this content what we have in this particular sample repository, and then let us know if you have any feedbacks or comments. Now let me quickly switch to All right. So the last section of this video, we are going to cover the memory capability of LangChain. So take an example of when you're interacting with an LLM, and you might have provided a lot more information to the LLM as part of the prompt that you have given, but LLM is not going to store that information by itself. So if I want to refer something that I have already provided, like let's say I've given my name and I want to ask the LLM what's my name, it may not know, it should not know because it is not storing that information that you have already supplied earlier. So LangChain is providing in-memory store capability. So in the chat template, what you can do that you can create a variable name, in this case a chat history, and then I can capture all this information that is happening the conversation happening between the user and the LLM, and I can store that information in a chat persisted storage. In this case, either in a buffer memory, or you can even store this one in a persisted store like a Cosmos DB or a disk cache. In this notebook, you can find the example as a conversation buffer memory here, but if you go to the API, you can find the example of a Cosmos DB as an implementation for the state store. So in this case, now what we're going to do there, the main difference between the previous example and here is that we are going to execute the agent executor with a one more addition of memory. So now when I execute this chain with the help of the agent executor, it knows that all this historical information that is available between with the conversation between the user as well as the agent, you have to store somewhere else so that it can refer that information. So that is exactly going to happen here. So now if you execute the same question that I have given to the LLM, you can see that the chat history, it's going to contain what was the human message, and the content was, my name is Shiva, how can I help you or help me? So all this information can be referred as part of the same communication here, so that if I ask something about what is my name, it can pick that information from the chat history. So LangChain provides multiple persisted store options available for chat history scenarios. So you can look into that. All right, so that's it. That's all about a high level overview of LangChain, and then we have covered information about like the agent, how we can use agent along with the tool for retrieving the data from Azure AI search, and how we can use the chat model, in this case Azure OpenAI. So I hope this would be helpful for your day-to-day work if you're working with Azure as well as with LangChain. And you can refer this repository that we have mentioned here. You can look into that, and if you want to specifically on some of the LangChain trainings, you can go to the deeplearning.ai. There are some great sessions delivered and recorded here by Harrison. He's the founder of LangChain. You can get this information from deeplearning.ai. So I highly recommend to watch this training series. There are more. I'm putting primarily two here, but there are more LangChain specific training series you can find from here. All right. Thank you all. Bye.